A uniform chain of mass m and length L is held vertically in such a way that its lower end just touches the horizontal floor. The chain is released from rest in this position. Any portion that strikes the floor comes to rest. Assuming that the chain does not form a heap on the floor, calculate the force exerted by it on the floor when a length x has reached the floor. Now what the situation is that we are having the floor over here on which we are having a chain of length L, and the situation becomes that on this floor x part comes down here, and we assumed that this doesn't forms a heap. So L minus x is basically vertical right now. So we need to consider an element of length dx at a distance x from the ground. I need to find out the force exerted when this is the situation. So I need to find out indirectly the force exerted by this dx element, rather when this dx element reaches the ground, right? So what I am going to do is, first of all, I am going to find the mass of this element, that is dm. So mass per unit length into length of the element. Moreover, I'll find out, what is the relation between the force. Basically, I can have in my mind, but right, what approach can I follow? This will be, I can find out the change in momentum of this in order to get the force, right? So I'll be working to see this change of momentum. So let me work the velocity of this dx element as it reaches the bottom, that is the ground. So that velocity will be under root 2gx, because x is the length below this dx element. So the change in momentum, or I should say the momentum transferred to the ground, is what? It is dm into its velocity, because initial velocity was 0. So that comes out dm to be m by L into dx into velocity, which is 2gx. Now we know that the force is basically the rate of change of momentum, that is dp by dt. So I can easily have that to be m by L dx by dt under root 2gx. So now friends, we have the here term dx by dt. What is it? It is simply the velocity, because velocity is dx by dt for this element, which is under root 2gx, as we found out. So I can write it as the force to be m by L under root 2gx whole square, giving me the value 2mgx by L. So this is the force, rather mark it as F1, that is exerted by this element dx as it reaches the ground. But what about this length x? Won't it apply any force on the ground? Obviously it will be. When this is the case, okay, this element has applied the required force, that is F1. But what about this part which is already lying on the ground? It will be having some weight, that is, it must be applying some force on the ground. So let us have that force to be F2, which is actually the weight of the x part. So that will be m dash into g. And what is m dash? That is mass per unit length into length of that part into g. So this is this. Now what is the total force? That is the force applied by the element plus the force applied by the length x. that comes out to be 2 mgx by L plus mgx by L, giving us a total force of 3 mgx by L. So this is the force exerted by this chain on the floor when length x has reached the floor.